All right, 2 is talking about solving linear equations, and you should remember how to do most of these procedures from pre-algebra last year. So here we have 2x plus 4 equals -6, and the big thing is equations, what you do to one side of the equation, you have to do to the other side of the equation. And so some students actually kind of put like a wall here, or at least you pretend that there's a wall. And what you do to one side of that wall, you have to do to the other side of the wall. Again, you do not have to draw that wall, but that's really what that is. So on this side, our objective is to get to x. So here, to get rid of a +4, we're going to -4 from both sides of the equation. On the left side of that wall, or the left side of the equal sign, these will cross out, and you're left with 2x. Over here, -6 minus 4 is -10. And then we're going to divide both sides of that wall, or divide both sides of the equation by 2. And then x equals, that's what I'm trying to get, x equals -5. And just as a side comment, you can always check your answer. So if you take your answer, -5, and you substitute it back in, so 2 times -5 is -10, and -10 plus 4 is -6. And so it does work. You can always check these equations. All right, on this one right here, this is -2, so we're going to add 2 from both sides. And just a quick comment, you can always draw that wall again if that is going to help you. But again, what you do to one side of the equation, you have to do to the other side. Keep it equal. And so these cross out, so you're left with -5x. 9 plus 2 is 11. And then finally, divide both sides by -5. So x equals -11 fifths. And you can keep it as an improper format. As long as the improper format is reduced. Okay, so that is reduced, but you are allowed to leave it as an improper fraction. All right, to solve this, first you use the distributive property. So 2 times x, and then don't forget about 2 times -3. And again, on that left side, again, if you want to imagine that wall, on the left side, you can add these two guys together. So -6 plus 4 is -2. And then it's just like the previous problem. So we're going to add 2 to both sides. Divide both sides by 2, and then x equals 5. And again, you can go back and check your answer. So literally substitute your answer in. You think that is correct. Well, substitute it in right there, and then figure out if it equals 8. All right, so you can always check your answers when you do these problems. All right, now on these, whenever you get to a fraction solving equations, you could still do it the exact same way as the other problems, but I'm going to show you a kind of a neat math tool. And all it is just what you do to one side of the equation, you have to do to the other. But sometimes students, when they see fractions, they kind of like, oh my, and they start to worry a little bit. Well, there's something you can do to get rid of all the fractions. Well, look at all the denominators. All of the denominators, try to find the common denominator. So between 4, 2, and 3, the common denominator is 12. So what I'm going to do is I'm going to multiply each of these by 12. I'm going to multiply this by 12, that by 12, that by 12. Remember, what you do to one side of the equation, you have to do to the other side of the equation. And watch what happens. So here the 4 and the 12 reduce 1 and 3. So now I'm left with 3x. Notice there's no fraction. Here, the 2 and the 12 reduce to 1 and 6. 6 times 1 is 6. No fraction. And then on this right side, 3 goes into 12. 4 times 2 is 8. And notice you're left with a simple equation with no fractions to solve. So we're going to -6 from both sides. 3x equals 2. Divide both sides by 3. And then x equals 2/3. Same thing on this one. Find the common denominator between them. Notice this 3 is a common denominator. A denominator. 4 is a common a denominator, and then 6 over 1. So the common denominator between all of these is 12. So you multiply each of the items by 12. Don't forget about this guy. Every item by 12. So here again, the 3 and the 12 reduce to 1 and 4. 4 times 2 is 8y. 4 and 12 go into each other 3 times. 1 times 3 is 3. Don't forget about your sign. That's a subtract. And then here there's nothing to cancel, but 6 times 12 is 72. And then you just have to solve this equation. So we're going to add 3 to both sides. I'm running out of room. So 8y equals 75. And then just simply divide both sides by 8. So y equals 75 eighths. And again, if that could be reduced, then reduce it. Okay, but there's nothing common with 75 and 8, so that is simplified all the way. Now, let's get to talking about consecutive integers. Now, consecutive integers are, like if I talk about integers, consecutive integers, I might be talking about 1, 2, and 3. Or I might be talking about 7, 8, and 9. Or 21, 22, and 23. Or even negative, so consecutive integers would be like negative 6, negative 5, negative 4. Right? And again, it follows the number line, by the way. So, so like 1, 2, 3, see, those are consecutive to the right. So negative 6, as I said a minute ago, negative 6, and then negative 5, and then negative 4. Consecutive integers, one after the other to the right on the number line. So here it says, find 3 consecutive integers. Now, when you get to algebra, this is not a guessing game. I don't want you to start guessing numbers and trying this number, trying this number, trying this number until you guess it correctly. What I want you to use is algebra skills. Now, it says 3 consecutive integers, and anytime we don't know anything in algebra, we're going to represent that as x. So my first number is x, because I don't know what my first number is. So that's my first number, and if you want to label it, let me call it this. Let me do it this way. So the first number is x. Now, what would the second number be? Remember, I'm talking about consecutive numbers. So notice 1, 2, and 3, 7, 8, and 9. Every one of these numbers, if the first one is x, that means the second number should be x plus 1. It's 1 more than whatever the first number is. Just like 7, then 8, then 9. It's 1 more than that. And then our third number will be x plus 1 more than that. So it would be x plus 2. So you're going to basically use this setup with this representing your first number, this representing your second number, and this representing your third number. So let's follow the directions. Find 3 consecutive integers. So that means I'm going to add these 3 numbers together. I'm going to add, that's my first number. I'm going to add it to the second number. And then I'm going to add it to the third number. Again, this is my first number. This is my second number. This is my third number. And it says find 3 consecutive integers whose sum is negative 36. And then what we need to do is just to solve this equation. So on the left side of that wall, remember on the left side, you can add like terms together. So combine my x's, that's 3x. Combine my numbers, that's 3. And then I can minus 3 from both sides. Now this over here is negative 39. Divide both sides by 3, and I have x equals negative 13. Now, if x is negative 13, that means negative 13 plus 1, this should be negative 12. And then negative 13 plus 2, this should be negative 11. So my 3 consecutive numbers are these 3 numbers right there. Negative 13, negative 12, and negative 11. Let's look at another one. Find 3 consecutive even integers. So an example, 2, 4, 6. 30, 32, 34. 3 consecutive even integers. So again, If the first number was x, if this is my first number, then the next number, notice consecutive even numbers, they see that 2 and then to 4, then to 6, notice they count by 2s. So this one would count by 2, and this would count by 2 more than that one. Again, think of 2, 4, and 6. So 2 plus 2, and then plus 2 more. So that's what I have. This is my first number. This is my second number. This is my third number. Find 3 consecutive even integers whose sum, so I'm going to add all these together. So x plus 2 plus x plus 4. I'm adding all 3 of those together, whose sum is 72. And then you can combine like terms. Minus 6. Divide both sides by 3. So x equals 22. So if x equals 22, then this is 24, this is 26. And those are my 3 consecutive integers. And again, let me highly suggest to you, this is not a guessing game. These problems will get a lot more complicated as the year goes on. So it's not just going to say whose sum is 72. It might say twice the sum, or it might say 3 times the sum and difference of 15, or something like that. So the whole point that I'm trying to emphasize is you need to set it up as x, and then x plus 2, x plus 4, if it's consecutive even integers. And again, just the same thing. Notice this is 4 consecutive odd integers. So again, an odd integer like 7, then the next odd one would be 9, and then 11, and then 13. So something like that, okay? Those are my consecutive. But I want you to notice with odd integers, what do they count by still? To go from 7 to 9, isn't it still counting by 2? And then plus 2, and then plus 2. So you're actually going to use the same setup. So you use this setup for even and odd integers. Make sure you pay attention to that, because you are still jumping by 2. When you go from one number to the next number, you're jumping by 2. So this is the same setup you're going to use on all of these. And it says 4 consecutive. And then we're going to add them all together. So I'm going to get x plus 2 plus x plus 4 plus x plus 6, and whose sum is negative 80. And then I'm going to add like terms. And then just solve this. And so if x is negative 23, and then plus 2 would be negative 21, and then negative 19, and then negative 17. So again, remember, it always follows the number line. So if negative 23 is here, it always follows it to the right. So then negative 21, and that's consecutive, negative 19, and then negative 17 to the right.